You know, some things in life are, well, they're pretty predictable. If you take the height of 1,000 people, you're going to get a nice, neat bell curve. But other things, like the size of a wildfire, or the impact of a war, or how wealth is distributed, they are just wildly unpredictable. Most of the time, nothing much happens, and then, bam, an extreme event comes along and changes absolutely everything. So what is going on here? What's behind this fundamental difference in how the world seems to work? Let's dive in.
So, here's the big puzzle we're going to try and solve today. Why is it that some parts of our world are so orderly, so easy to forecast, while others seem to be governed by pure chaotic chance? Well, the answer lies in understanding two fundamentally different kinds of statistical games that reality is playing with us all the time.
On one side, you have the world of averages. This is the world we all learn about in school, the bell curve. Data clusters neatly around a middle value. Think about things like height or IQ. Sure, there are extremes, but they're incredibly rare. And then you have the world of outliers. This is a totally different beast, a place governed by what we call power laws. Here, extreme events aren't just possible, they're what define the entire system.
The secret ingredient to the nice, safe bell curve is one simple idea: addition. The classic normal distribution happens when a bunch of small, random things just add up. Think about it. A person's height is the sum of their genetics, their nutrition, and countless other little factors. Because these effects are additive, they kind of cancel each other out, pulling everything toward a stable, predictable average.
To really get a feel for this, let's take a quick trip to a special kind of casino. We're going to play 3 really simple games, and each one is going to reveal a little bit more about these two different worlds, and why it is so crucial to know which game you're playing in life. Okay, so we're at our first table. The rules are dead simple. We're going to toss a coin 100 times. For every single head, you win $1. That's it. This is a purely additive game. Your wins just stack up one on top of the other, and with a 50-50 chance, you can pretty reliably expect to walk away with about $50. And if you were to play this game 100 times, your results would form a perfect, beautiful bell curve right around that $50 mark. You'd have some small variations, right? A lucky streak here, an unlucky one there, but it all cancels out. This is the predictable world of averages in action. Simple. Okay, now let's move to the second table. This is where things get interesting. You still start with $1, but for every head, you multiply your money by 1.1, and for every tail, you multiply by 0.9. Now we've just switched from adding to multiplying, and that one tiny change, as you're about to see, changes everything.
This multiplicative process creates something called a log normal distribution, and it reveals a huge shift. Your downside is capped. You can't lose more than the dollar you started with. But your upside, the upside is practically unlimited. A long string of heads could lead to an absolutely enormous payout. And this creates a distribution with a long tail, where a few incredibly lucky players win big, creating massive inequality.
And now for our final table. This one's a famous puzzle. It's called the St. Petersburg paradox. You start with $1 and you just keep tossing the coin until you get ahead. With every tail you flip, the payout doubles. So get ahead on the first toss, you get $2. Flip a tail then ahead, you get $4. 2 tails then ahead, $8, and it just keeps going. So what's the average payout for this game?
Mathematically, the expected value of this game is infinite. Yeah, you heard that right, infinite. The chance of getting a huge payout is tiny, sure, but the payout itself is so ridiculously massive that it completely breaks our normal intuition about averages. We've now officially left the world of predictability behind.
And with that, welcome to the world of power laws. In this world, concepts like average and standard deviation, they become totally meaningless. There's such a heavy tail of extreme events that the more data you collect, the bigger your average gets, because you keep running into these massive outliers that just skew everything.
This quote just nails it, doesn't it? It perfectly captures the idea. In a power law system, one single data point can be more important than all the others combined. It's a world where the exception isn't just an exception. It becomes the rule that redefines the average for everybody else.
So we know what a power law is, but why? Why does nature produce these bizarre, almost alien distributions? Why isn't everything just nice and orderly like the bell curve? Well, the answer comes from a really fascinating concept in physics.
The engine that actually generates power laws is called criticality. It's this idea that some systems exist in a really delicate balance, perched right on the very edge between total order and complete chaos. Okay, picture a magnet. When it's really cold, all its atoms are aligned and perfectly orderly. When it gets really hot, they're just flipping around randomly. But right at a specific temperature, what we call the critical point, something incredible happens. The system is perfectly balanced. It's not ordered, it's not chaotic, and patterns of all different sizes can emerge at the same time.
And what this means is that at that critical point, the system becomes incredibly sensitive. A tiny disturbance, a single atom flipping its magnetic spin, can trigger a chain reaction that just cascades through the entire system. A small cause can lead to an effect of literally any size, from a tiny flicker to a massive system-wide shift. The outcome becomes completely and utterly unpredictable.
And here is the truly mind-bending part. A lot of complex systems in nature, they don't need to be carefully tuned to this point. They drive themselves there naturally. A forest, for example, it just keeps growing denser and denser until it's perfectly ripe for a fire. This makes megafires not some freak accident, but an inevitable consequence of the system's own dynamics. The same thing happens with earthquakes.
So, how does any of this apply to our economy? Well, it turns out this isn't just some abstract physics concept. These very same rules govern huge parts of our modern world, from business and technology all the way to creative industries. Some businesses, like a restaurant or an airline, they live in the world of averages. They have to rely on consistency. They can't have one amazing packed night make up for a whole year of empty tables. But then you have other businesses, like venture capital or book publishing. They operate entirely in the world of outliers. Their whole strategy is to place a ton of bets, knowing full well most will fail, all in the hope of finding that one runaway success.
And if you need proof, just take a look at the returns for venture capital. The numbers are absolutely staggering. A tiny, tiny fraction of investments, just 6%, are responsible for the vast majority, 60%, of all profits. The entire industry is basically funded by these incredibly rare, massive home runs.
This quote just says it all, right? You aren't trying to find a portfolio of average successes. No, you are hunting for the one investment that is so wildly successful it pays for all the failures and then some. It's a totally different mindset.
So what does this all mean for you? Well, the most important lesson here is to figure out which game you're actually playing, in your career, in your investments, or even in your creative projects.
Because this means you have to adopt your strategy. If you're in a world governed by the bell curve, consistency is everything. Your average performance is what truly matters. But if you're in a power law domain, like starting a business, writing a book, being a content creator, then persistence is what counts. You have to take many, many intelligent shots on goal, because you only need one to change everything.
Because in a world that's shaped by these power laws, we're all kind of living in a critical state. Most of our actions, they're barely going to move the needle. But every now and then, one decision, one email, one single idea can trigger a cascade that transforms your entire life. The system is maximally unpredictable. So the question is, are you ready for that?